The next project is very recent. It's the last project we worked on. It's Nest. Nest is a lab in Dübendorf. It's basically an infrastructure to allow for the building of temporary units that are placed, you see here in the section, on cantilevering slabs, like in a shelf, and are, as I said, temporary and are sort of low risk because everything that they need to exist, to survive, let's say the media, the staircase, the fireproofing, the structure, infrastructure is already there and is provided by this, what we see here, that is the backbone, and this is the backbone we built. So this looks like this in reality. It's very differentiated, how do you call, I can call it, building plots, you know, with different depth and different orientation. You know, there is a limit to. This was not our idea. The client came to us and asked us to develop a form for such a concept, give it an architectural sort of shape. Their wish was to go beyond what is normally understood as an experiment in the lab. You know, in building technologies. I'm talking now here very much about energy systems, control systems, facade materials, and so on. And what they normally do is they develop things often in simulation. Then they do the next step. They build scaled models or mock-ups or sections, but it's always under ideal conditions. You know, for example, these solar decathlons exist since many years. This is competition where industry and university meet once a year or every 2 years somewhere, and everyone brings its ideal house. You know, and then they set up everything on a south slope on a perfect day, and then they measure who is the best one, providing the most energy, and this is not the reality, because the reality of the city, and even more the reality of the dense city where we are heading to, is that there are no two identical situations, and for a good place there is always a bad place on the back. You know, if you have a housing block, you have the street on the north and the street on the south. You have the houses on the hill and the others. And Nest is sort of the simulation of such a real neighborhood, because you have this differentiated, and I'll show also here a small video about it, this differentiated situations, you know, that happen to be, that are then occupied by different research teams in this case, that have to interface to each other to communicate in, you know, in terms of energy, is sort of part of the, it's part of the program itself. And this is also the reason why we were very fascinated by this task. You know, I would ask, you will ask, I will show you digital fabrication on this building in a minute, but the building itself for us was interesting as a design job, because it's really questioning a lot of our, you know, traditional way of designing, where things are already clear in the beginning because there is a long history of references to how you do something, you know. And here it was complete, it was tabula rasa, because you have very strong formal references from the 60s, but they are only similar on a formal level. You know, if you think at the Capsule Hotel in Tokyo and self-building projects in Berlin in the 80s, you know, where the user was involved. There it was always about ideology. And here it's sort of a infrastructural program, you know, where this change, you know, is part of the game. Now, what I want to show you here in particular is this ceiling system here that you see now. And I want to show you how we implemented and did this. Talking about this one. This is cylinders, aluminum cylinders, extremely lightweight cylinders. It's almost no material, no weight. It's like a beer can. You know, it's only the stability comes through a border that is folded. And what we did is to glue them together. You see here the process in a way that allows, through the use of a robot, to shift them slightly, one in relationship to the other. So to get out of the plane. You see the robot just places a few dots of glue, comes here on the stack and places the cylinder. And the results, you'll see in a minute, is highly informed panels. Super simple, you know, because it's exactly, you know, these panels are normally used just built on a surface, you know. Highly informed, unique panels that are hanged from the ceiling. They create space with almost no material, you know. And again, it's a design process that starts from the understanding of how something could be built, you know, and then reverse engineers from one side, you know, what the possibility would be, you know, how much modulation do you really need in a space? It's like the cube with these 8 millimeters. What is needed, you know? Then looks if this is possible, if you can build something like this, or does it tip over? And on the other side, it addresses the design space, you know, and with these rules, it populates it with elements.